in this I'm going to tell you exactly about the active power, reactive power and apparent power. Okay, so you buy a cup of beer. Okay, so in maximum like 80% of the cup is filled by the beer, right? That you have to pay for it. But you can say that 20% is froth. Froth means the, you can say the jug of the beer, right? So this is the actual beer is known as active power. Okay, the froth which is of no use, but still you are paying for that, right? You are paying for the whole glass, correct? But this froth is of no use, but you have to pay it for that. So this froth is known as the reactive power. Okay, and the combination you got it for the apparent power. The beer which you are actually consuming, which you are actually drinking, that is the actual thing. So that is the active power which is consumed by the load. Okay, but you have to pay for the whole cup. So froth is also there in the beer, obviously. Then that froth is the reactive power, which we don't want but will have to take only in the case of inductor and capacitor. Okay, and the combination which we need to pay, that is the apparent power. Okay, so I told you one thing, if there is a resistive load that will consume active power. Okay, if there is an inductive or capacitive load that will consume reactive power, and if there is a combination of RL, RC and RLC, there is a consumption of apparent power, right? So in resistive load, as we just studied, phi is equal to how much? 0 in case of resistive load. So P is equal to how much? VI cos 90, and Q is equal to how much? VI sin 90, right? And S is equal to VI. So cos 90 is how much? No, cos 90 is 1. Okay, cos 90 is, tell me, sin 90 is how much? Okay, sin 90 is 1, and cos, sorry, I put 90 here, it would be 0 only because phase angle is 0 now. So do it for sin 0. Sin 0 is 0 and cos 0 is 1, correct? So P is equal to VI cos 0. Cos 0 is 1. So P is how much? VI. That is equivalent to apparent power. Correct? As you can see that VI sin 0. Sin 0 is 0. So in case of resistive load, there is no reactive power consumed. Right? So Q would be equal to 0. Understood? Now similarly we can take it for inductor or capacitor load. Here phi angle is how much? 90 degree. So P is equal to how much? VI cos 90 degree, and Q is equal to how much? VI sin 90 degree. Correct? So in this case cos 90 is 0. So P is equal to 0 and sin 90 is 1. So Q is equal to VI, that is equivalent to S. So that exactly proves that resistive load consumes which power? Resistive load consumes active power, that is P is equal to VI. Okay, and inductive load and capacitive load consumes reactive power, that is Q is equal to VI. That's why we always say that inductor and capacitor does not consume power. By that they mean inductor and capacitor does not consume active power. Okay, but in question paper they generally don't mention this active power. They always mention why inductor and capacitor does not consume active they always mention why inductor and capacitor does not consume power. They didn't mention the whole thing, that is inductor and capacitor does not consume active power, and you can show this by using this formula. Okay, by this formula you can show this, that inductor and capacitor phase angle is 90 degree. You can draw the phasor diagram also, that in inductor and capacitor current is either lagging or leading by an angle of 90 degree. So if phase angle is 90 degree, so in that case cos 90 is 0. So active power consumption is 0, but there is a consumption of reactive power that is equivalent to Vi, and that is equivalent to apparent power. Okay, got it?